So the Microsoft Cloud Adoption Framework is a bunch of best practices and guidance that Microsoft employees, partners and customers have put together to help others on cloud adoption journeys. And that's so you can learn from maybe the mistakes or bad practices that they've done within their journey. Now, the Cloud Adoption Framework is split up into different sections, so you can dip in and out depending on where you are on your cloud adoption journey. So if you're just starting, there's some guidance on how to build that business case and convince your senior leadership team on how to move forward into the cloud. Or if you've already got workloads running within the cloud, there's a section on Manage, so it can help you implement governance and controls within your environment and move forward there as well. The best thing about the Cloud Adoption Framework for me is that it's open source, so if you want to contribute to it, you can open up a pull request on GitHub and contribute to that documentation. So if you're on that cloud adoption journey, please do have a look at the Cloud Adoption Framework and get involved and enjoy.
Hey there, it's your buddy Jay. I am back. Welcome to the first Azure FunBytes of 2021. I am really thankful to have you all as my viewers, and I'm glad you stuck around with me into the new year. It's really great to see how much fun this is to do. A little music here for you. Getting started today in the new year, I wanted to show you that little video with Sarah about the Cloud Adoption Framework. And the reason why is that cloud adoption is one of the big reasons why we do Azure FunBytes. Azure FunBytes is not just about me showing off something every week. It's really about me helping you understand the different parts of Azure. And yes, I'm live with StreamYard, but I'm going to put that little minimal one there. I want you to understand that there's all these different parts to Azure that you have access to, that you can work with. And in your journey into the cloud, you're going to need to pick up some things here and there that are going to make it a little bit simpler for you to understand the big services that Azure brings. And so that's why we do Azure FunBytes. It's not just for demos. It's not just for, product. I'm here basically because I want you to understand that there are options for you to begin using Azure. They are not just upload some data into a virtual machine that you created. There's so many different services that Azure provides. And today, we're going to go back into the weeds. We took a walk around the very outside spaces that were Azure Functions. And today what we're going to do is I'm going to bring in a guest that's going to help me understand Azure Functions just a little more. And last time, this person, right before the new year, he helped me out, and it's time to bring him back. It's Maxime Rouiller. Why don't you unmute yourself? Thank you very much, sir. How are you doing?
Pretty good. I wanted to do the joke like, sorry, your mic is muted, but I thought at that point, like, it's getting redundant.
That's a 2020 joke. We're past that. Nowadays, we're just like, can we just get to it? Can we just?
I know we're 2021 now. Everyone should be able to, like, if you don't know how to unmute your mic by now, like, come on, you had a year to practice.
Yeah. So here we are. We're into 2021. Greetings to you from the Great White North that you are in. We're
Montreal.
Here. Yes, and I'm here in New York City, Brooklyn to be specific. And what we're going to do today is to dive in a little deeper what we did last time. And so what is that? That's Azure Durable Functions. That's our focus today. We talked about just last time .NET, Azure Functions. We delve a little bit into how the services within Visual Studio Code can help simplify your entry into the process. And so what I think we should probably start doing first, Maxime, is just let's give everybody a quick reminder on what it is that we do with Azure Functions, how what the big idea is. So I'm going to go ahead and share this with us really fast. Give me 1 second. Let's stop screen. Let's share screen. And so what I will do, because we're doing it. We're doing it live. Sometimes you're going to listen to me do it this way. We're going to talk a little bit about what the big subject is. It's Azure Functions.
Yes,
Azure
sir.
Functions is it's in the world of technology now. We like to use this term called serverless, and Azure Functions is the Microsoft Azure implementation of serverless application deployment and development, all the different things that we associate with being able to run executable triggered code, as opposed to something that is compiled on a server or in a container that we're going to be working with. We're more concerned, and tell me if I'm wrong, we are more concerned with the executable code that is going to be doing something, as opposed to all the underlying infrastructure that supports it.
Yeah, you are totally right on this. So early on in our days, we were very concerned about the bare bone machines and all the power supply and the UPS and those kind of things. And then we started moving towards a more infrastructure as a service, where we started caring more about now the VMs. So we need to still configure like Windows on them, set up security and AD and all those kind of stuff. But then at some point, people started moving more toward what we call platform as a service. And at that point, you're just caring about your HTTP server where your application is going to be hosted. So you still need to install your frameworks. You still need to install your code, but you still have too much to manage. And the next evolution of that is more like serverless, and it's this functions where you don't really care about if the OS behind is Windows or Linux or a Raspberry Pi. It does not really matter. As long as the code can run, you're good. All the other question that remains that were left from the previous days are answered already. We will take care of this. The only answer that you have to provide is what amazing code will you write with this framework.
And so what we're going to do is talk a little bit about what we're seeing in front of us right now, which are, these are value proposition images that show you a little bit about what exactly people are going to get out of it. So we can see it here, but I'm going to show the overlay a little bit.
Yeah.
And so this is a basic piece of documentation from the main website. I'd hope you maybe take a moment to talk about it. And so this is specifically, if I'm right, this is a durable function. Am I right?
No, this is actually just a basic function. So this is a basic function where anything can trigger a piece of code. So those triggers are also called events. So they can be timers, HTTP requests. They can be coming from other services as well, like messages and new files being created and stuff like that. And that trigger will create this input binding that will allow you to pull in some data from that specific event and allow you to run your own code. And whether after that you have something that can be processed, that would be the output binding, where maybe your function is going to save somewhere, or your code is going to provide some answer. If it's an HTTP request, it might be your HTTP response in that case.
Gotcha. So what we're going to talk about really fast, and I wanted to bring this up. This is a great image, and you and I talked about it before the show, and I think it's really valuable. This is the kind of difference between stateless services and stateful. And so I'd like you to kind of I know how to say it, and I like to think of it as one, we have our data, the other one, we don't have our data available, and we're getting it from somewhere, but maybe you can say it prettier than me.
All right. For me, the difference between this stateless and stateful service is it all depends on when your code starts. Do you have any context of who's running this code? Do you have any context of what your application is in its current state of running? And in most stateless application, you start from nothing. You maybe have, for example, the ID of a product. Then you don't know what that product is. You don't have any description about it. You don't know who made the request. So you have to pull all this information in from different storage. And when you're more into stateful case, which is a little bit more the case with durable functions, is your application just resumes execution where it left off, or it keeps on going its process where it left off.
So that's example microservice B here.
Yeah.
Whereas a gateway is then sending whatever that gateway service. In this case, it's Azure Functions. This is just a genericized version of the difference between stateful and stateless. This is not specific to Azure, but the idea works the same. This is a really cool little image that shows some of the security value propositions of using this and the way we can get information about what exactly our different functions are doing. Yep. And so I think this is really interesting. We've got so much valuable tools to work with that help us get the most out of Azure without having, like I said, to really do that big, heavy lifting of software deployment architecture. And so one of the things, let's just bring them up that, like I said, is our big subject today is Azure Durable Functions. That's what you and I want to talk about. And so let's start from the start, shall we?
Oh, yeah. Let's do
this. The start is explaining what exactly a durable function is. And so what I'd like you to do is just give me the 1 minute version of what I'm reading all here.
Okay. So I think the first 5 words is actually first 5 words actually is amazing. So a durable function is an extension. So it is plugged on top of your current Azure Functions. And what it allows you to do is basically orchestrate a process and allow that process to be expanded to multiple functions. So if you want to call another function from a function, this is where this thing can go. And those execution don't need to be all within like a minute or within a few seconds. Those processes can start for a longer time. So those are the definition of what we call a workflow. Mm-hmm. And we will today just talk about the basic one. So we're talking about the orchestrator function. We're not going to be talking about stateful entities or stuff like that. But basically, it allows you to create very complicated pieces of business logic with minimal amount of code and relative easiness. But it is more complicated in Azure Function a little bit more.
Great. And so everybody watching, always remember we have chat availability. If you have questions, you can use our YouTube stream by going to aka.ms/jgordon on YouTube, and I will go ahead and share that in our chat. Also, if just going to put it up on our banner, or I should say our visible chat, and I'll overlay it. And also we've got, of course, our YouTube chat. We've got our Twitch chat. So you can go to Twitch again at twitch.tv/AzureFunBytes. And if you like, we would really, really like for you to give us some of your questions because Maxime's here and your input is paramount to making sure that we cover what you want to hear. And so let's get back into it, Maxime. And then eventually I'd love you to kind of show me. I know you have some pre-prepared content that you can give us, but we're going to just do a big idea here and just talk about some of these like main subjects. So we've got orchestration identity.
So I think this one we can skip for now. This is just basically just a GUID. Each identity, each orchestration has its own identity because it is a separate process. You're starting a workflow, so it needs an ID. Those are just the limits of what it is. So you can basically type whatever you want. It just must not start with the @ sign and not contain a few characters, but otherwise it can be pretty much anything you want.
Sure. So our unique identifier is where we start. That I just wanted to let everybody know. And then we go to reliability and the different things that we get from it. The big idea is we have these replay patterns that can work correctly and reliability, and our function code must be deterministic. In other words, it has to have some sort of finality from start to finish, correct?
Correct. And one of the things that they mean by deterministic is that the same result is always returned every time. So if you're writing into this orchestrator function, because there's two concepts we'll need to talk about later, is orchestrator function and activity function, which we'll get to in a few minutes. But if you're writing code into an orchestrator function, it needs to be deterministic, which means if you're using datetime.now, for example, this property returns a different date every time it runs. So this is not deterministic. This is dynamic, and it will change every time, so we don't want to do that. You don't want to read from the disk because the content may change. You don't want to do random numbers because, of course, this will change. So the result always needs to be the same based on the input you give it.
Great. So now let's take another, while we're taking this really, really high view of what's going on, I brought up the Durable Functions versions overview. And so we're on the 2x version of Durable Functions with entity functions available and these durable entities so that we can, I would imagine, continue. Let's take a look at what it says durable entities are. Define operations for reading, updating small pieces of state. So that's, I'm guessing, making some sort of like maybe database changes. Just give me that 5-second version.
So the 5-second version is, if you've ever looked at the actor model in any code platform, this is similar, but there's a reason why we're not calling it. It is not exactly what it is. But for example, if you have a shopping cart that has your name on it, this will always keep this shopping cart alive with your name on it. It's going to be its own, for example, entity. And whenever you come back, this thing is always going to be there. So, but that shopping cart does not need to be in your database. It can just be something that is temporary for the time being for the execution of your program. If you're fine with that, you can keep it that way. But of course, if you want to persist it to your database, you can do it.
Great. So let's get a little bit into durable HTTP. It allows us to call APIs directly from orchestration functions with some limits. Implement automatic client-side HTTP 202 status polling, and then built in, and I guess that'd be useful for things like change streams and Mongo for polling updates. And then you could tell me if I'm wrong.
Yeah, so the way we were doing HTTP requests before in Durable Functions was in .NET, for example, you would create a new HTTP client and you would start creating your headers and your stuff, and you would have to do all of this stuff all by yourself. But then there were a problem with handling the HTTP client, like open port. Are you disposing of them properly and stuff like that? So one of the things they did is they wrapped up all HTTP execution within their own process. And since HTTP requests can technically as well be a problem in terms of being deterministic, they basically solved that problem by just re-implementing it as if it was a different function that you're calling.
Gotcha. So one of the things we should start talking about are how we're going to create these functions, how we're going to work with them. And I know you have a ton of information. So I'm going to remove myself, and I know you have this. And so I'd love you to kind of like, is this a great starting point for you of the information you'd like to share, or you want to bring it back? It's up to you.
I can jump around, no problem here, but we can start with this event sourcing stuff. So
sure, let's vamp.
Yeah, let's go with that. So event sourcing basically is how the magic happens within Azure Functions. So durable function. And every function, every orchestrator that you're going to start will start what we call an execution history. And this is what we call basically event sourcing, because you're never changing the state of a single line. You're just appending on top of them. And at the end, it's the combination of those actions that makes up the state of your system. This is sourcing. So the orchestrator function will schedule async work, and then it will just shut down. And we'll restart and rebuild this local state in a very periodical manner. That gives us a whole bunch of different improvements. So things like improved performance and scalability, because now the orchestrator and activity functions are maybe running on different machines or maybe on the same machine. but it allows you to really scale really fast. But also the concept of eventual consistency, as in we don't really need to have all of this saved as soon as possible. As long as all the histories are in order, we can always rebuild our state and know what happened. And on top of that, that's one of the biggest selling point of event sourcing, and not just in durable functions, is that event sourcing give you the full audit trails and history of your execution. So if you want to have a very nice animation on a very simple code that we will run later on, but with additional infographics, which just basically show us how the execution is going to happen. Do we have time for that?
Sure, let's do it.
All right, let's do this. So when you're going to run, like this piece of code at the top is part of the orchestrator code. We're going to call line 1 and 2 and 3. So when you're going to call the orchestrator function from any of our triggers, so we're aware of triggers by now. It can be HTTP, can be a timer, can be from anywhere else. So the orchestrator function will be called, and when it starts, this is where on the right you will see the execution history or event sourcing, basically. So the code will run. Line 1 is super simple. It's going to go over it. It will create an empty list, and then it's going to do an await on a call activity async. And the parameters in here is the name of the function, and B is going to be Amsterdam will be the parameters we want to send to our function. This is not going to call the activity function right away. The first thing it's going to do is going to look into our execution history, basically say, did we call this function before? Like, do we have any result like from that function that was called previously? And the execution history on the first run will say, nah, you're good. Like, there's nothing. So at that point, we're not calling activity function. We're scheduling the work. And that's what we see on the right. The task will be scheduled for activity function to start. And once this function is scheduled to start, the orchestrators will just complete. There's no problem. It's just going to shut down, and it's going to wait for activity function here to pick up. Activity function, the schedule will be done behind the scene by Azure Storage queue messages. So automatically, there will be a trigger that will be invoking activity function with the proper parameters. Here we see hello Amsterdam. That will be the code that will run behind the activity functions, and it will return just this hello Amsterdam. Of course, at that point, the activity is completed and the return has been done. And the orchestrator at that point will know that something happened. So it will restart again, and this time it's going to run the code just like it ran the first time. It's just it doesn't know what happened. So behind the scene, it will look again at the execution history, retrieve hello Amsterdam directly from the history, and at that point, the execution history is basically informing the orchestrator function that, yeah, that function is run before, and we have a result now. And once this is done, we will move finally to the outputs. We will return hello Amsterdam as a list, and we will be done. And at that point, the orchestrator is completed again, and the execution is completed, and everything is completed.
And so our serverless durable function is executed. We go through the app, we go through the orchestrator, we get to our activity function, and then we have auditing or information about I shouldn't say auditing. We have information while auditing does exist. We have an execution history, so we know what happened, when it happened, how it happened. And then what we can do is look in things like application insights that we have associated with this to actually check on performance. And so these are things that after we kind of put one together, we'll show some of like those little extras on how everything kind of comes together, the glue.
So just with those basic building blocks, there are interesting patterns that I like to talk about. I know there are more on the website, but there's basically two or three that I love to talk about. And the first one that I like to talk about is what we call function chaining. Because we used await in this case, we can basically just take the first output of the function and feed it into the second, and take the second and feed it into the third, and so on. So those are chaining, and you don't really need to have X, Y, Z. Like, you don't need to feed one into the other like directly as is. But anytime you're using await and waiting for the next one until the first one is executed before you run the next, This is what I call chaining. This allows you to run a series of technically serverless events in the very sequential ways that before might not have been as easy to orchestrate yourself. And all of this is handled for you. You don't need to write special code. We wrote the code already. You just need to do those await, and those functions will be automatically done for you.
So now we're having these like tasks that run sequentially.
Yeah.
So there's the first one, and we call it. So we're going to talk about it here, if you don't mind highlighting it. So let's go over to F1. And so what we're trying to tell them is that if F1 occurs, after that, you're supposed to go to F2. And you must complete after you've waited for them. So that's a big thing that we should talk about here, is that that await is specifically telling the function, the orchestrator function, do the first one, wait for it to complete. Do the second one. And there's that finality that we need from our functions. They need to have a start and an end, because if they don't have that end in these chains, we can't continue our process. We're going to get stuck, and that becomes our little single point of failure, even in serverless.
Exactly. So we need to have this whole thing happening behind the scene. If you remember the animation I showed earlier, this process of waiting and re-executing and the orchestrator coming back, this is happening here on every line. And every function is only going to be called once. Because that's the power of event sourcing, is that once an activity has returned a result, it does not need to run it again. It already knows what the answer will be. We're just waiting now on F2, for example, for it to complete before we move forward. And only when F2 will be completed will we get to F3, and only when F3 will be completed will we get to F4. And what I like to tell people is, think about how you would implement it yourself with messaging, so that you're not directly calling a function within your function. Because in our case, we're not calling function directly. This is all messaging. So we don't have like the orchestrator running, then calling function 1, then calling function 2, function 3, and function 4, and then having literally 5 functions at the same time running concurrently and billing you for the time, like for all the time this one takes to run. Like, the orchestrator will schedule the work for F1, and then it will shut down. And it will wait for this to run. So even if F1 takes, for example, a minute to run, well, the orchestrator is already shut down. It does not need to come back again to do anything. It just has to wait until F1 is done.
Cool. So we've got our function chaining. What do we got next?
Okay, that is one of my favorite. This one, I call it the fan out, fan in. And it's basically a way for you to scale out, like literally in terms of function.
Sure. And just a reminder to everyone, these are different patterns that we're going over. I want you to make sure that these aren't, clear definitions of how you need to do it, but these are examples of different patterns that Maxime's provided us on how to implement it. So let's continue on. Can you go back one step just so we can... And so this is his fan out, fan in. So create the beginning of a function, expand it, store your data, reduce the size, if you will. So this is kind of scaling the enormity of these.
So there's, for this pattern, for example, here, we're going to mix a few things. So let me just take my mouse so we can see it. So that line here, work batch, we call F1, and we await for it because we want to have a list of all the items we have processed that we have to work through. So this will provide us a list, and that's fine. This is the same one as the chaining that we saw earlier. But then things get funky, as in you're looping through the whole work batch. But if you're looking here, right before context call activity async, there is no await. We're just returning a task. We're not returning a function. We're not returning the result of the function. We're just returning a task. We're not awaiting for it. So the orchestrator will not wait. It will call F2, it will schedule the work with that property, and it will add it to our list that's at the top here. And only when this whole list has been scheduled, then we will wait for all that work batch to be done. So this is massively different from before. Before we were waiting for each of them to run in sequence, and this may not cause any scale up like on your Azure Functions. But now imagine that this work batch has 1,000 items in them.
Mm-hmm.
If there's 1,000 items, that means there's going to be 1,000 Azure storage messages that are going to be sent. So that will automatically trigger Azure Functions to just scale up.
Okay.
Or actually scale out.
All
Sorry.
right.
So
rather than going vertically, we're going horizontally.
Yeah, we're going horizontally now. So instead of having a single server, you're getting to 2, 3, 4, 5, 6 until the queue is under control. And that list does not need to be 1,000. I already put it could be 100,000.
And just so everybody knows, these are basic scaling methods on the web. Sorry to interrupt, Maxime. I just want to make sure we're throwing some of these basics and fundamentals, that these two different types of scaling methods of just making an instance larger or adding more out, that these are basic concepts of internet scaling. And so what we're talking now about is going horizontally and taking not just more a bigger server, but more servers, if you will. Go ahead.
Yeah. If you're in consumption mode or premium mode, it will vary a little bit in terms of what kind of server you get, but it does not really matter at that point, because what we're talking about here is about reducing the size of the queue, and you don't have personally to take care of this. Azure Function will take care of this. So depending on your code, if you only have 10 items here, you might scale maybe to a single server and then back to one within a few seconds, and you're going to be fine. But if you're running like 100,000 items, then you may scale to 50 servers or maybe even more to control all those amount of run that you have to do. And once all of this has been done, it will scale back all the way back to 0 once all of this has been completed. Mm-hmm. And so when all those tasks have been completed here, then we have this last function. In this case, it's doing a sum of all the integer that has been returned. As we can see here, that activity returns an integer, so a number. And this one will just do a sum. But think about something that maybe is calling APIs, or something that is calling databases to do operation on like cleanup operation on your different tables, and it's returning for you, for example, result of like that table I cleaned, that amount of records or stuff like that, like summaries of things that it has done. Then what you can do at that point is you can have a summary of all of your operation that were done. And in the last one, we're still awaiting this call activity. I think we're going to save that result, because that's what we did all this work. We did all this scaling. Let's just make sure we save it somewhere.
Got you.
And it does not need to be saved somewhere. You can also call an API or whatever you want. This is still just very flexible. But the power of this here is, again, think about how you would create an architecture without all of this coded for you.
Yeah.
Like all the error handling, the what we call transient error. Like the storage right now is not responding for like a second. What are you going to do? Like there's an error. Like we recover from that. You don't have to handle that. So all those different problems are already solved. And like I said earlier, like what kind of amazing code do you want to write? And we'll take care of the rest. Like this is literally the definition of it.
Gotcha.
So,
all right, cool. Go for it.
If you want to do, we have one last pattern that is a little bit, it's a little bit more funky. It's a little more funky.
And then we can get a little bit into, if you have some things to show us specifically about how to create and execute a durable function, like we kind of did last time around a standard function, that would rule. Because we got about almost 40 minutes, or I should say almost 20 minutes left.
Okay, so I have two more things I want to show. The pattern, and I want to show important details and limitations on the durable function things. After that, we can actually jump into the code and be ready to be amazed.
Wonderful.
All right, so this one we call it the human interaction with timeout. So nice image because this function will basically say, hey, I want to request an approval either from someone, and if there's nobody at the door, like somebody's on vacation, is not responding, I want to escalate that process. So let's look at the code, real time. So in this case, we're going to do the request approval. So this maybe sending an email, maybe doing anything that would maybe Slack message or Teams message to basically say, hey, I need you to approve that. And then the process is going to start. So we have a due time. So we need this task to be completed within 72 hours. And we have a timeout. And we're going to create this timeout by using our create timer from our context. That is our first task. That's the first task that we will wait for.
This so is we're just adding like some finality there, if you will. We're adding an endpoint. If there is a lack of completion by the actual by this, then what we'll do is we've got a timeout and some sort of wait, and then we can see here there's an else escalate process. So go for it.
Yeah. So the create timer is just like an activity functions. You have to think of it the same way because it will behave exactly the same way. And then we have this line here called wait for external approval bool. So you're going to say true or false, it was approved or not, but it will be mapped to an approval event. That approval event can be triggered from any other function. It can be triggered from pretty much anywhere. You just need to have this event called. And once this event is called, it will complete and return either true or false. And again, just like in the fan out, fan in pattern, we await. But this time we're not waiting for all of them to complete. We're waiting for any of them to complete. So either the approval event or the timeout. And whichever comes first will be the one that will be returned over here. So if it is the approval event, then we will cancel the timeout because we don't want this to be running any more longer. And then we will call just handle the approval. If it's approved or refused, we'll do it whatever the way we want. But if it's not the approval event, that means that we spend 72 hours waiting, and then we need to escalate. So we're going to run this different process. But here's the magic things. Like when we get to that if line, you're not being charged for the time you're waiting. There's 72 hours if there's nobody there. Like the worst case scenario is nobody's responding and we have to wait for the durable timeout to happen. The only time you're going to be charged is when that durable or that orchestrator checks on the status. Gotcha. And that's it. And that lasts like a second. And you're not going to be charged for 72 hours of runtime. You're not going to execute something for 72 hours. This function is going to wait until there's something to do before it actually triggers back. So those are long-running processes, and it can last for a long time. And I think it's pretty amazing.
I agree. And the thing I love about it is, like I said, you've got ways to ensure that it's completed, that it's finished. And if it doesn't finish, one of the things I like that we could potentially do here also is create a logic app. And what we can do is associate our logic app with this serverless application or this Azure function to identify that maybe in this like timeout that maybe the escalate function actually sends something to a logic app. And that logic app sends out notifications via email, text, you name it, and lets someone know X function didn't finish. And maybe it's because it's dependent on another service for its state. And we can talk a little bit about where state gets stored as we go along. We've got a few minutes. But state being stored is also a trigger, if you think about it. A new change to state can kick off another function. And that's the thing that's really important here. So let's talk about the idea of like multiple functions in your previous example. One thing happens, it puts information into a state, it may trigger another function. And so what we do is start chaining these things so we accomplish all the individual tasks we need, whether that task is acquiring data, manipulating data, notifying people about modifications to data, or even taking that data and creating something like a report right out of a serverless function that's triggered by an initial action. So maybe that initial action is every day at 2 o'clock in the morning, what we get is an inbound data dump from another service. And maybe based on that inbound data dump, which is our state, means that it triggers a new session that creates a report. And then our team gets the report that gets brought over to a logic app, and that logic app delivers the application via its distribution using some sort of service. Or build it into this. Access an email gateway on your own. You can build email gateways within Azure to be able to send a notification out, or natively use SMS services through one of our communication tools. Go for it.
So one of the things that everyone has to remember is this is not a different product than Azure Functions. This is running on top of Azure Functions. So everything that you've seen right now so far, you still get this million free execution of Azure Functions. We do not differentiate here. So even managing databases or certificates or stuff like that, because, for example, we have triggers in Event Grid where you can be notified in advance when a certificate is about to expire. So what are you going to do, right? This process is not a single function that you can call. It's something that you're going to have to request and do long-running processes. And Durable Function is going to be able to do that basically for free for you.
So I want to talk about one thing before we get into. Do you have something else to show? I'm sorry. I think you said you had one more other thing.
I have one more thing. Let's not talk about sub-orchestrator, things to know, language support. There's a lot of information online. So I want to just talk about this one right now. So this is super important because it links back a little bit to what we were talking about earlier, and it's the orchestrator code is replayed on every reiteration to restore the local state every time. So do not put things weird in there. So the function calls may not be replayed because event sourcing, but in the outputs remembered. But you have to know that the orchestrator, like we said earlier, has to be deterministic. So no IO logic in there, no random numbers, and especially don't write infinite loop, because since there's an execution history for a specific orchestrator, if you write an infinite loop, that execution history will be infinite. So there are workarounds that we have in our doc around that. So you have to use those workarounds. If you want to have the date, as you saw earlier, we were using the date, but this one was taken straight out of the context, not datetime.now. So we have workaround like that for those kind of scenario that will need those kind of information. I just wanted to make sure that we covered those three.
Gotcha. So you got anything else you want to show us before we bring up one more subject before we go into a demo?
I have one last thing that might be interesting.
Sure.
Reminders, durable function run in user space, so this is not a different product. It uses and behind the scene uses Azure Storage, so queues, tables, and blobs.
You found what I wanted to talk about next.
Exactly. So it's about queues. So everything that you see in the activity being scheduled and things being running again, even the timer, is all based on queues. So that is what that's what we're using all the time. And then there are tables, which is all of our infinite sourcing for input, output results, and the whole history of every functions. And blob is basically for anything that is too large to fit into a table. So if you're transferring, for example, 100K of JSON data, well, yeah, it is going to end up in a blob because the table is going to be table columns will be too small for this, so blobs will be used for that. And do remember that exception, errors, or whatever things that you have on your end is a valid output for a function. So if you have 100,000 function that all throw in exceptions, you're going to have 100,000 exception in string format that will be deserialized every time the orchestrator unserialized. So you have to be careful about that. Better log them into application insights than just return them as actual output.
Gotcha. I put a link in just real quick. to this, and this is really important. So these are the four main storage services that are associated with an Azure function, and we'll go through real quick. An Azure Blob Storage, ideal place for throwing unstructured data that we need to store just in some sort of flat file, if you will. So let's say, like you mentioned before, Maxime, you've got a bunch of JSON that you need to store somewhere. This is a first idea. Azure Files, more about let's modify, access, work with files on a file system. So those of you who know what SMB is, or a shared disk on a Windows machine, this is kind of where we're going. We're going for Samba mounts on Linux servers. We're going for these Mac drives or LUNs on Windows machines to be able to manipulate, edit, access these files. Queue storage, and if I'm right, this is for our queuing service. We have a message coming in and we want to bring it to our function and we don't want it to be overloaded. We're going to be storing this in our queue. That means that you need to have that service created. And then table storage is more specifically about storing tabular data, if I'm right.
Yeah, tabular data that is not like Cosmos DB. Cosmos DB more like a document database. The table API on our end is more like kind of a NoSQL single layer table. So at the beginning, there's only a few predefined columns that are system wide, but then you can just push in an object in there with different properties, and suddenly the column will get created automatically. So you don't have to think about this. But it is not SQL, so there's no relationship between two tables. So you have to take that into consideration, of course.
So we've reached the demo portion of our show. We got
the fun part.
About 10, 12 minutes to kind of go over this. So I'd love you to show me from here and then into the portal how you create a durable function. And the only reason I'd like to see it after you've up to the portal is, like I said, I just want you to give me a quick, like, these are the supportive services that come along with a function. You know, all those little ticks that you can see within the portal, the things that people can know that they have accessible to manage their functions with.
That makes sense. So I will just say first that we did not create this from, I did not do a lot of things here. So I just created the standard Azure function that we were doing before. So I went into Azure, I created this, and I followed the little tutorials that we had earlier. The difference here is that let's just bring that back. When we're at the create a functions type, I just used the durable function orchestration. That's what I used. And in C#, that will create you the code that we're going to see here. So let me just close this and collapse that for now. Is that clear enough?
Yeah, looks good.
All right. So we have this function here, and it's the same code that we saw earlier, right? We say Tokyo, Seattle, and London. We have all those kind of things. And the difference here, for example, we're going to see the orchestrator. So this is defined by the orchestration trigger. And this is the definition of our orchestrator. This is the workflow we're going to follow. So this is super simple, of course. We're not going to bring that more complicated. Those are activity function as defined by the activity trigger. And it takes in a parameters of name, so a string. It will just do a little log and return the name. And then we have our proper trigger. And that is one of the interesting part you have to remember, is that an orchestrator will not start all by itself. It needs to be started by something else. So it can be an HTTP, can be a queue message, can be anything. So in our case here, it's the same HTTP trigger we're creating before in our previous discussion. The only difference here is that we have a durable client that has been added to it. So the durable client here will allow you to have this object, and this object will allow you to start a new execution of your orchestrator. We still need to call them by name, but the thing is, the same recommendation I did earlier by basically saying you can do take this and do a name of this object, so your function name can be renamed properly. It still applies, but we're going to keep everything as default for now. And by default, we can see here that we can specify, for example, instance ID, just like we were talking earlier. But if we don't want to specify it, we can just leave it to null, and it will automatically generate it and return it for you right here. And finally, there's a function here that will be called create check status response, and this is just an HTTP response that will give you URLs for you to check on the status of your execution. So let's run this code.
Like a health check kind of thing, if you will.
Yeah, it will basically display the status of your durable function call. And I'm going to press F5 right now just to start this function. I hope everything works. If everything doesn't work, I'm sorry. I have a terminal issue, by the way, on my machine. That's why I debugged it back to you. The reason why the func host start in the last show didn't work is I have a terminal problem with my Azure, my VS Code, and my own thing. So I managed to make it work. So I'm going to take that right now, and we're going to test it out locally. So let me just open up here. My tabs may be a little bit small, but I'm going to zoom in as soon as I get a chance. There you go. So we have a status query. I'm going to click on that real quick, but we'll see here that, okay, the status is already completed. So that was quick because, of course, the outputs are simple. But let's put a different spin on it. As you can see here, we have an instance ID. We will have a different instance ID that in a second. So let me just go back here. And this time, I'm just going to add something very, very bad. You don't do that. System.threading.thread.sleep. You don't do that. And we're going to wait like 2 seconds for each message to show up. And we're going to restart the function. I hope it's working. Like I said, I do have... Yeah, let's stop the whole thing and disconnect and restart.
Okay.
I have terminal problems.
Just starting like the build and execute process, if I'm
right.
Okay. And we can see you just using Windows to build, or a Windows container, if you will, to build what it is you need here. I think it uses a container, correct?
No, not this one. This one is just .NET.
Okay. So it's just using your local .NET. I got you. Yeah. If we wanted to do it, we can do remote execution for our testing and have it do everything in a container. In this case, you're just using your local .NET installation on your Windows machine.
Exactly. So right now I'm just going to run this, and it will take a few seconds. And then I'm just going to open that up again because I want to make sure that we're having a version of this. So our HTTP start is going to trigger, and we're going to get to the status. And of course, this time, as you can see here, it is still running. We didn't start with any input. We didn't start with any custom status. So if I refresh, boom, now it's completed.
Oh, so, there we go.
So you can have a static endpoint like that where you can trigger, right? If you want to make sure that only when this orchestration has been done, you can still keep on triggering this until runtime status is reached, either completed or whatever else. And you'll see when there was the last time it was updated.
Gotcha.
Yeah. And this is kind of amazing. And of course, you wanted me to put that on the cloud. So let's see if we can push that to Azure. So let's disconnect. It's going to kill the function. And
remember, everybody, you're going to want to install the Durable Functions extension.
No, just the Azure.
Oh,
this one is just Azure Functions. Just Azure Functions.
Okay.
You don't need.
Great.
You don't need anything else. It comes with it. It's just. It's part of a different extension. So if you're
gotcha.
If you're installing it for the first time, it will do add this extension over here.
Gotcha. Thank you for clarifying that.
But it is pretty transparent. You don't need to do anything about it. Let's do Azure and then my own personal. We want to publish deploy to function app, and we can just follow the new function app in Azure. Globally unique name. So Azure AzureFunBytes Durable. Oh, yeah, it doesn't take this. Okay. Maybe dash. Yeah.
Works for me.
Me too. .NET Core 3.1.
.NET Core.
East US is fine, I guess.
And so now it's going through the process of creating the function, creating the plan, or the hosting plan that it'll be under. Then it creates the actual storage that our function is going to need to be in. And that's all within the context of a resource group that everything is stored within.
Right. And if you go into the output in the Azure function here, you will see logs of everything that is going on. So, of course, you can just follow the UI, but it is available also right here. So we'll see like which SKU are being used. It's creating application insights. So we have a whole list of the things that are going on here. This is not opening automatically for us, but I kind of like the way that this is progressively creating all this stuff for us.
So it's creating our underlying resources, the ones that we don't need to manage. And that's the whole point of this. We don't need to manage these resources. We're going to allow Azure to do it. And because why? We're not doing things like lifting and shifting things into the web or into Azure. We're not doing a partial refactor and then putting things onto a server or in a container. We're allowing Azure to do all the big, heavy lifting of the actual execution and presentation of these different code pieces of code that we turn into functions. And like we mentioned before, in a stateful pattern, these will be accessing and potentially manipulating and eventually presenting data that is stored from our apps or from other places into a Cosmos DB to hold state. So if we need a database that rather than use a flat JSON file in a blob, but we can do that too. And the benefits of using a database is that different ways to actually deliver our data, maybe more coordinated with our different applications. We need to maybe do things like ETL in order to actually provide that, and doing ETL into a storage blob, or it just may not make sense for us. So what we're doing is we're running the rest of our function deployment, and then what we'll see is, so if you mind just bringing up the portal for a sec, because we've got about 4 minutes left, and I just want to give them, while that's still updating, we saw what's going to happen. We saw the execution. I want to give everybody just a quick preview of what's been created in the portal. And then once we do that, I think we're going to start wrapping up. Sound good?
Sounds good. So I hope we're going to have enough.
I need that extension.
Yeah, me too. I turn it off all the time because, like, when I'm not doing things in the portal directly, like, this is not something that butters me too much.
Sure. Well, you know what? If it doesn't finish executing, it's not a big deal. I think we showed everybody from that intro when you did it locally exactly what the function is doing. And what's great is that you can test your functions locally, so you can run it through your standard test suite if you'd like to. Make sure that what you're expecting to happen happens. Unit test, you name it. So here you go. Here's the function that you actually created.
Yeah, we're going to take the function URL, copy the clipboard, and we're going to run that and do just HTTP start.
And you get your fully qualified, and there we go. There's your function.
And it's run here. Let's get the status. It is still running. It's completed, and we're on Azure websites.
Hell yeah. We did it, man.
Hey! Where we failed earlier with simpler Azure functions, now we completed with something way more complex, which is a durable function. But it's fine. It's fine.
We did it, man.
Yeah,
we got through another session together.
Yes.
We taught everybody a little bit more about Azure Functions. We got a chance to talk a little bit about what's going on moving forward if you want to build these things. So we've got 2 parts for you, everybody. We had the first one from before Christmas. I hope you really got something out of it. If not, I will make sure that you get more out of these sessions. And I think that's what today was. You got even more. We tried our best. Maxime, thank you so much for being part of this today. I hope you have a great start to 2021. And hopefully we can do this again about another subject and help people learn how to use Azure. So thank you very much, Maxime. Let's say goodbye to everybody. How can they find you on the internet, by the way?
They can find me on the internet by going into my on Twitter. So I have a Twitter handle twitter.com/Maxime Rouiller. And of course, my keyboard is in French, so it's weird. But yeah, let me just fix that up. Here you go.
No big deal. Whoa.
Yeah, Maxime Rouiller without the E for Maxime, because I don't know, I was a teen when I created that, so yeah, I know I was
Very cool.
You can find me on Twitter. You can find me on GitHub. There's a whole bunch of different places. But of course, if you're just looking for my name, like on Bing or on Google, you will end up either on my blog or even there on my profile of Microsoft Cloud Advocate profile. And at that point, you have access to pretty much like everything that you need.
Great. Well, that's it for us. We'll catch you all next time on Azure Fun Bites. Thank you so much. Later, Maxime.